Hello, Fruitport High School chemistry students. This is Mr. Kovalak here with our next lesson. So today's video, I want to teach you about weighted average and in the chemistry example of weighted average of average atomic mass. How did we get those numbers on the periodic table of average atomic mass that we've been talking about? So the real value of this lesson is learning how to do weighted average. So average, you know how to do average. If I asked you to average two numbers, you'd add them up, divide by 2. Or a regular average of 5 numbers, I'd add up the 5 numbers and divide by 5. But a weighted average is a little bit different. We use weighted averages when calculating your grades, right? Like the final exam counts as 20%, the rest of the semester counts as 80%. Maybe your teacher has that broken down into projects are this much, quizzes are this percent, tests are this percent, daily work is this percent, and all those percentages should add up to 100%, of course. So that's a weighted average, and the value of knowing that's important, right? You could do that if you work in business and budgeting and stuff like that. Also calculating the value of things. I know that I love watching sports, and so NBA and NFL drafts, I'm really impressed. A little bell there for you. Really impressed with how teams will come up with a way to rank players, and they use averages for that. Maybe one team values their speed or another team values their experience. They'll weight those, not just qualitatively, like that's more important to me. They'll actually quantitatively calculate the value of a player based on numbers. So today we're going to learn about that. So our first example, I want to ease into it, okay, and talk about how grades are calculated, all right? So let's say that for maybe for this class, this would be practical, right? At the end of the semester, you have your grade is a B plus, 87 kind of percent, and the final exam you're predicting you're not going to do very good on. It's 65%. So these are kind of like the points for your score. And over here, this is showing the percent that each is worth, right? The final exam counts as 20% of your overall grade, and the other work counts as 80% of your grade, right? So how do you calculate your overall grade? Okay, well, we do this mathematics. We multiply these numbers. And so we take 87 times the weight it's worth, but when we type in how much a percent something is worth weighted wise, we move the decimal point over. So 80 becomes 0.80. And when I multiply 87 times this number, we get 96.6. And then you'll do the same thing with these numbers. You'll take 65, not times 20, but by 0.20 because we moved the decimal point over. And we get an answer of 13. And if we were to add those two numbers together, we would get 82.6%. That would be your final, calculated grade that goes on like your permanent records of the high school, right? And so one way to show the weighted average formula is to look like this. Now, if you were to do grades, right? If you want to do overall grade, right, what you would do is you would take the total sum, and the fancy letter in accounting or computers is for total sum is to use this Greek letter called sigma, and you would take your current grade times the percent that grade is worth. Okay, and then we do the total exam. So the current grade on like one part of the class might be a better way to say it. So if you had an 87% on your daily work and you take how much is your daily work worth, what'd you get on the final exam times the final exam, the percent's worth. And then the sigma looks intimidating, but that's just this over here where we just added up the numbers. Now this was pretty easy because there's only 2 categories, but if you had 7 categories, you'd have to do a grade on one part times a percent 7 different times before you added it all up. Okay. For this class, we'll practice weighted average with this chemistry example. The average atomic mass number that you see published on the periodic table takes into consideration the mass of each isotope and the percent we find it in nature. So how heavy is an isotope times the percent abundance that we find in nature. And you'll do that as many times as you need to. If there's 2 isotopes, it's pretty easy. If there's 6, it's a little bit more work. And then you'll add it all up at the end, okay? So to do one first example is let's talk about chlorine, okay? So chlorine is around in 2 isotopes. Chlorine comes as one isotope weighs 35 AMUs. The second chlorine comes around in 37. That's the only ones nature finds. And I found that chlorine 35 is around 76% of the time, and chlorine 37 is around 24% of the time. Notice that these percentages add up to 100%. If the percentages don't add up to 100, something went wrong, okay? So just to double check, 76 times plus 24, and that equals 100, okay? So we are going to use this formula. We're going to take the mass of 35, multiply it by 76%. We'll do the same thing with the other isotope and add the numbers together. So to do that, here's my first one. I'll take 35 times 0.76. Notice I moved the decimal point from 76 here. Move it over 2 places. That is how we like to work with it on a calculator, 76%. And then chlorine 37, we'll take 37 times 0.24. Now, you can type this in the calculator in one, if you're pretty good, you can do this in one giant step. 37 times 0.76, finish the parentheses, plus parentheses, 37 times 0.24, and it turns out to be 35.48, which is what I wrote down here. Now I can check if we did it right by looking at the periodic table. Is in fact the average atomic mass number on the periodic table for chlorine 35.48? Well, if I look, it's 453, I guess. That's pretty close, so that makes me feel good. Probably it's not exactly right because 76.0 and 24.0 are not what nature makes. I think it's really like 76.15. Like there's some more numbers, digits that I rounded. Okay, so that's how you do that. Okay, that's how you do this formula. Average atomic mass. Sometimes we don't even use the formula to answer a question on a test. We just kind of use estimating and logic. Let's say we wanted to study titanium. Let's say titanium comes as titanium 47. I don't even know if that's true, but let's just go with it. Titanium 47 and titanium 48. And the question is, which one's more common in nature? Well, is 47.9 closer to this 48 instead of 47? Well, the answer is yes. So this would be more common in nature. That's not so that you can take some estimating and do some numbers like that in class. So you probably do that for sulfur, right? Sulfur's average weight is 32. I'm guessing the average isotope, the most common isotope for sulfur, is the one that weighs 32 AMUs. Another classic example to do a practice problem with is with carbon, okay? Carbon comes in 3 isotopes, remember from last class. Carbon weighs 12, 13, or 14. And carbon 12 is around 99% of the time. Carbon 13 is less than 1% at 0.9%. And carbon 14 is 0.1%. So if I want to use the average atomic mass sigma formula, I'm going to have to take this times this, and this times this, and this times this, and then add up all 3 of those subparts together. A lot of students make mistakes on this one because it's a little harder to pull off. Notice that for 99%, I typed in 0.99 on the calculator. It equaled this number here. And most people remember to move the decimal, but this one is a little trickier because of all the zeros. So 13 times 0.009. If I move this decimal point over 2 spots, I have to have zeros that kind of hold them. So 0.009. And 0.1% gets put in as 0.001. So if I take the mass times the percent for all three isotopes, here's my subscores. If I want to do this step one, then do this, and then they do this, and not do it all in my calculator in one step, but do the sigma, the total sum afterwards, we get this answer, 12.011. And you know what makes it feel really good? Hey, look at that, 12.011 on the periodic table. We nailed it. We got it right. All right, so I hope that you can appreciate that weighted average is different than regular average, and we'll do a couple chemistry examples to practice that on the ChemQuest 9. Actually, let's talk about the ChemQuest 9. The ChemQuest 9 here, I'd like you to, if you're watching this video, don't tell anybody. We'll see who didn't watch the video. I'll let you skip the first page. This is supposed to kind of get you into the swing of things by talking about grade average, which I don't want that to confuse you. I do want you to do the last 3 pages, and we got a nice chart to fill out, some questions, and so on. And what I'd like you to do is just round the masses. So what do I mean by that? You'll see I have some numbers blocked out, and then just use 87. And that number's blocked out. Use 85. It's because magnesium 24 doesn't exactly weigh 24. It weighs 23.985 because the definition I gave you from AMU is not 100% accurate. But just round that to 24. And for the isotope that weighs 25 for magnesium, just use the mass of 25 and so on. So all of those blacked out numbers, you can just round those to the whole numbers. I did that for you. All right. All right. Cheers.